In this video, we'll graph this function f of x equals x plus x over the absolute value of x. And it's that absolute value thing that might throw some people off. So let's take a look at just this part, just the x over the absolute value of x. So let's evaluate. I'll make a little table here. We have x, and we have x over the absolute value of x. So when you plug in x, if you plug in 0, of course, you will get undefined, because you can't have 0 in the denominator. Or I should say, more clearly, we can't allow the denominator to equal 0. But what if you plug in a negative number? Negative 1, well then you have negative 1 in the numerator, divided by the absolute value of negative 1, which is negative 1 over positive 1, which is negative 1. And it works with all the negative numbers like that. I'll give one more example. If you plug in negative 2, you have negative 2 over the absolute value of negative 2, which equals negative 2 over positive 2 equals negative 1. On the other hand, if we plug in a positive number, positive 1, 1 over the absolute value of 1, well, that's just as 1 over 1, which is 1. Again, with 2, 2 over the absolute value of 2 equals 2 over 2 equals 1. So this part will be either negative 1 or positive 1, depending on what x is. So now we can start to build what we call a piecewise-defined function. So I can say if x is less than 0, let's get that in there a little bit better. I'll put a little bit of space there. If x is less than 0, we'll say that this is x minus 1. Because if x is less than 0, we're always going to have a negative 1 right here. So x minus 1, or plus negative 1 if you want to see it that way. If x is greater than 0, I'll write that in here. If x is greater than 0, then our function will be x again, but plus positive 1. X plus 1. So I can write this more fully as a piecewise-defined function. F of x equals this piecewise-defined function. Now we can graph this a little bit more easily. So when x is greater than 0, that is an open circle because 0 is not included, then we have x minus, or x plus 1 if x is greater than 0. That looks just like this. If x is less than 0, we have x minus 1. All right. That is a y-intercept of negative 1, and then it's x still. So it's the function of x being graphed up to where x is 0. So when x is less than 0, it's all this, this, this. And then when x equals 0, you can't have it. Then when x is greater than 0, it's graphing this. Real quick, just to close everything up, the domain is all of the possible x's. It looks like all real numbers except for 0. We can't have 0. So the domain is from negative infinity to 0 and 0 to positive infinity. And I've got the rounded parentheses, meaning 0 is not included. The range it is also going from negative infinity to positive infinity, but it's not including negative 1, that little area, that range from negative 1 to positive 1. So negative infinity up to negative 1, and then continuing on at positive 1. But again, 1 is not included. We use the rounded parentheses up to infinity. Okay, I hope that helps.